Pokemon, gotta catch 'em all. 11.4. Area of regular polygons. Now, you have to go back way back at the beginning of the book to remember what regular polygons were. All right, so a regular polygon is all the sides are equal and all the angles are equal. The square is the most famous one. The square is all the sides are the same and all the angles are 90 degrees. So that's a regular square. But a hexagon can also be regular. When all the sides are the same and all the angles are equal, we have a regular hexagon. We can have a regular pentagon and then a regular triangle as well. And so let's look at all of their parts. Here we have the radius. We've only known like circles have radii. But these shapes have a radii as well. There it is. It's just the distance from the center to the vertex. And so they have radii. Central angles. When you put two radii together, they make a central angle. The angle with vertex at the center and two consecutive radii as the sides. So this is called the central angle. Boop. I'll draw it in. Boop. Boop. And how do we find the central angle? How big is it? What do you think? Well, I know a whole circle makes 360 degrees. So how do I just find the central angle? It's a good guess. You just divide it by the number of sides there are. So if this has 6 sides, it's just 360 divided by 6. If the square has 4 sides, it's 360 degrees divided by 4, and so on. There it is, 360 divided by n, the number of sides. And then we have something new called the apothem. Some people call it the apothem. I call it the apothem. The apothem is the distance from the center to the side. So that piece, the red piece. So it's the distance from the center straight down to the side. And that's going to be important in a little bit. All right, let's do an example. Let's find the area of a regular triangle. Now the formula for area of a triangle is 1/2 base times height. Unfortunately, the base is not there and the height is not there, but actually the base is there. You can figure it out from pretty easily. The base is 4 because it's a regular triangle, so all sides are equal to 4. But the height is not there. But we do know that this is a 60-degree angle because all the angles are the same. And so we have 180 divided by 3 is 60 degrees. There's the height. How do we find that height? Well, if you remember back to last chapter, trigonometry, we can, there's a few ways to find the height. You can remember the special right triangles for a 30, 60, 90 right triangle, or you can use SOHCAHTOA to find the height. So your choice. I'll use special right triangles for this example. I know that this piece is 2, if you remember. If you half the hypotenuse, you get 2. And then what do you do to get the long side? 2 square root of 3. All right. So using trigonometry to do that, we have 1/2 the base times the height. Multiply it together. You get 4 square root of 3 units squared. All right. But sometimes they give you less information. All right, so here's another example of a regular triangle. You have to find the area, but this time they only give you the radius. All right, so how do you find the area when they only give you a radius? Here's how you do it. Go ahead and draw in the apothem. Remember the apothem was that vocabulary word, the distance from the center to the side. which makes a little triangle on the inside. It actually makes a right triangle. And then the hypotenuse is 12. But that's not enough information to find stuff. So how do we know what the angles are? How do we know what this angle is? Well, if I drew in another radius, remember this was called the central angle. To find the central angle, you just do 360 divided by the number of sides. In this case, it's 3. So 360 divided by 3 is 120. 120 degrees. But we don't want the whole central angle. We just want half of it. And that's what we get 60 from. So we have another 30, 60, 90 degree right triangle. Kind of cool. We know that's 6 if we use our special right triangles, and we know that's 6 square root of 3. Special right triangles rules. I know you had to memorize those rules last chapter, and now you have to use them in this chapter. And you're going to have to use them a lot, so try to memorize those rules. All right, to find the area of that tiny triangle, it's 1/2 base times height, which is 18 square root of 3. But all we did was that we found the area of this in here. But how many of those do you think are in this whole triangle that we're looking for? Here's another one. Here's another one. Here's another one. And then 2 more. This one and this one. So there's 1, 2, 3, 4, 5, 6 of them. So if we multiply by 6, we get the real answer. All right. So that's how you do it. But there's actually a shortcut way. It's not really a shortcut way, but there's a nice little formula that we can use to find the area of all regular polygons. All right. So the formula is area equals 1/2 apothem times perimeter. The little a stands for apothem, and the p stands for the perimeter of the whole shape. All right. There it is, the apothem and the perimeter of the whole thing. So it's basically what we just did, but all into one little formula. Let's do another one. Find the area of this hexagon. All right, and they give you the radius is 16. I drew in the other one, gives us a triangle that is 60 degrees, central angle, just because it's 360 divided by 6. But we don't want that. We want just half of it. That's the apothem. There's our little triangle. There's the 16. Now it's 30 degrees. Use a little bit of SOHCAHTOA, or if you want to use special right triangles, that's going to be 8. That's going to be 8 square root of 3. That's the apothem. So here's the formula. 1/2 apothem times perimeter. There it is. The apothem was the 8 square root of 3, and the perimeter is just this whole thing. We found out that half of it was 8, so the whole side is 16, but then there's 6 of them all the way around. That's why I did 16 times 6 to get the 96. And so multiplying that all together, we have 384 radical 3 units squared. All right, so it's the same thing we did. It's just now there's a nice little condensed formula to use. One last example for the day. A pentagon. Ooh, I love pentagons because it's kind of tricky. You think it's tricky, but I mean, you think it's easier, but it's a little bit tricky. Good news, this one, they actually tell you what the apothem is. They tell you the apothem is 20. Let's draw that little triangle. That angle is 36 degrees. Remember, the whole central angle was 72, just because 360 divided by 5 is 72, and then we took half of it to get the 36, which now we no longer have a special right triangle. You have to use SOHCAHTOA to find that side. How does the 36 relate to the 20 and the x? It looks like it's opposite and adjacent, which is tangent. Tangent of 36 is equal to x over 20. Multiply or find out what tangent of 36 is. Multiply both sides by 20. And we found that x equals 14.5309 approximately. So that's only this piece. You would have to double it to get the whole thing. Not only that, once you get the whole thing, you have to go all the way around to get the perimeter, 145.3085. Plug it into the formula, 1/2 apothem times perimeter. The apothem they gave you at the very beginning was 20, and the perimeter we just found out. Multiply them all together. You should get about 1,453 units squared. All right, kind of fun. We're using a lot of information that we've learned before. All right, so go ahead, try the homework.